Alright, so we really only have like 2 problems left. There's multiple questions for each, but 1 question on each page. We'll go through these. Whatever's time left, you'll have to do homework or whatever. Tomorrow, though, we'll do our free response. And that's about the quiz Wednesday, but that's about the entire week because we have a short week, so we'll figure out what we're going to do on Thursday then. Yeah. Alright. The table below shows the values of a rational function g of x. The equation of g of x is such that the denominator of the function is the quadratic expression 2x squared minus 4x minus 6. So that is just the denominator. So they give you some x values down below and some g of x values. So if you plugged in x, they give you all those values. And we're going to try to answer all the questions below. So before we really get started, since this is the denominator, let's try to factor this a little bit, and it might help us answer some of the questions. So first we can factor out a 2. Then can it be factored any further? After you factor out a 2. I think we can get x minus 3, x plus 1. Okay, so again, this is the denominator. We have a 2 out in front. X minus 3, x plus 1 are our factors. So let's go to question number 5. What is the domain of g of x? So they're strictly asking just for domain. What would our domain be? You can use the table to help you. Does anybody have anything for the office today? I don't think so. Thank you. Have a good day. We're going to go from negative infinity to where? Where's the first value we have to stop? Negative 1, yeah. It's undefined in the table. Then we go from negative 1 to where? 3. It's undefined. And then we go from negative 3 to infinity. That is the domain. Yes? Yes, sorry. It is 3. Thank you, Marie. Negative 1 and 3. Alright, does either factor in the denominator also exist in the numerator? Give a reason for your answer. So look at your factors that we factored at the top. Remember, these are the denominator factors up here. And then look at your table and try to determine if any would be in the top and bottom. Rebecca? Okay, how did you notice or come to the conclusion that it was a point or a discontinuity or a hole?
Well, on either side of the point of discontinuity, the values are very close together.
Exactly, they're both approaching the same value. So we're going to say, since x is approaching negative 1 from the left, or since, let's say as x is approaching negative 1 from the left, and as x is approaching negative 1 from the right, g of x approaches negative 0.5. If you look, we're approaching negative 0.5 here and approaching negative 0.5 on either side of that undefined. So we have a hole there. So x minus 1 is a hole. So x plus 1 is the factor. So that's the factor that would be on the top and bottom. And that's what they're asking for. Any questions about that? Again, approach -1 from the left side, look at it from the right side, and we can see that they're both approaching -0.5. Does either factor of the denominator not exist in the numerator? Give a reason for your answer. Again, these are the denominator's answers at the top.
X minus 3 since it's the vertical asymptote.
Yeah, x minus 3. So we're going to say, as x approaches 3 from the left, g of x approaches what? As you go to 3 from the left, what does g of x approach? Right? Negative infinity. We jump from -8 to -99,998. We're going towards negative infinity. And as x approaches 3 from the right, g of x approaches, this time as positive infinity. So x equals 3 is a vertical asymptote. So x minus 3 is the factor. Alright, based on end behavior, where does g of x have a horizontal asymptote? Give a reason for your answer. Where is there a horizontal asymptote? Give a reason for your answer. Go ahead.
2.
Okay, at 2. How do you know that, or what were you looking at to see that?
The end values on the table, one's 1.98 and the one's 2.02.
Yeah, we can see we're approaching that value of 2, but we have never actually crossed it. So y equals 2 is the horizontal asymptote because as x approaches negative infinity and as x approaches infinity, g of x approaches 2. Both of the n values are going towards 2 but never actually cross it. Alright, number 9. What must the leading coefficient of the numerator of the equation of g of x have to be? Explain your reasoning. So think about those 3 roles that we had written about horizontal and slant asymptotes. Well, we know this is a horizontal, not a slant, so we can get rid of one of the roles. So there's 2 roles we need to think about. How can we determine what the leading coefficient needs to be on the top? Go ahead.
Well, one of the ways we can determine this is it doesn't fall on the x-axis.
Okay, it doesn't fall on the x-axis, so we know now there's 2 roles that we don't have to worry about. There's only one. So that rule tells us what? To find the horizontal asymptote, if it's not y equals 0 and it's not a slant, what do you have to use? How do you find the horizontal asymptote if it's not those 2 roles?
The leading coefficient of the numerator over the leading coefficient of the denominator.
Yes, the leading coefficient of numerator over denominator. Do we know the leading coefficient of the denominator already? Marie, you're shaking your head yes. Do you know what it is? It's 2. We don't know the leading coefficient of the numerator yet, but we know that the answer has to be what? Where is our horizontal asymptote? It's at 2. So what does the leading coefficient of the numerator have to be? It has to be 4, yeah. Okay, since y equals 2 is the horizontal asymptote, let's say, the value is formed by the ratio of the leading coefficients. Again, so that's just a statement of that one rule we use. We're taking the ratio of the leading coefficients. We know the leading coefficient of the denominator is 2. So the leading coefficient of the numerator must be 4. It has to be, because 4 divided by 2 is 2. So that gives you the horizontal asymptote of 2. So all the same ideas we've been using, again, just using the table to answer these. Does anybody have any questions about any of these parts? Doing okay with them? Yeah, go ahead.
Is this the rule of how it has to be like top heavy or bottom heavy?
Yeah, that's part of that rule. So on this one, if it's top heavy by 1, you have the slant. If it's equally heavy, so the same power on top and bottom, that's when you use this rule, the leading coefficients. And then if it's bottom heavy, it's always at y equals 0. So those are the 3 rules that we're referring to, yes. All right, let's go ahead to the next page. We have one problem left here. The graph of a rational function h of x is pictured to the right. Use the graph to answer the following questions. What are the domain and range of h of x? So using your picture to the right or your graph, we need to find domain. Who can tell me what the domain is? Go ahead.
Negative infinity to negative 4 with a union from negative 4 to negative 3 with a union, and then negative 3 to infinity.
Very good. So the two values, negative 4 and negative 3, are the values that can't be used, vertical asymptote and whole. Very good. Who can tell me the range values? Values of the range. Marie?
It would be negative infinity to negative 7, and then negative 7 to 2, and then 2 to
Very good. The y value of your whole and the y value of the horizontal asymptote are the two you can't include. Very good. Negative 7 and 2. What factor is in the denominator that is not in the numerator? Explain your reasoning. In the denominator but not in the numerator.
X plus 4.
Okay, how'd you know that? It's a what?
It's the vertical asymptote and it's a non-canceling factor in the denominator.
Very good. Since x equals negative 4 is the vertical asymptote, the factor x plus 4 is only in the denominator. And it's because it's a vertical asymptote. Again, we know it's non-canceling. It's only in the bottom. Very good. What factor is in the denominator that is also in the numerator? Explain your reasoning. Factor in the denominator that's also in the numerator. Good.
X plus 3, which is x equals negative 3, since it's a whole and it's a canceling factor in both numerator and denominator.
Yep, very good. Since x equals negative 3 is a whole, and again you can see that on your graph, the factor x plus 3 is in both. And that's because it's a canceling factor. So it's a whole, it's in both. Any questions so far? All right, moving right along then. 13. What factor is in the numerator that is not in the denominator? Explain your reasoning. Factor in the numerator that is not in the denominator. Think about what the factors in the numerator find. Marie? Okay, so we're going to say since x equals 1/2, again, that's where you cross the x-axis right here up on your graph. Okay, so since x equals 1/2 is a 0, the factor, how do you think we're going to write this factor?
2x minus 1.
Yeah, 2x minus 1. Again, we have that 1/2. We can get rid of that fraction. Write it as 2x minus 1. Multiply everything by 2. So the factor 2x minus 1 is only in the numerator. Again, x minus 1/2 is not incorrect, but when you multiply it out at the end, you probably would have to multiply by that 2 to get correct leading coefficients and y-intercept. All right, 14. If a is the leading coefficient of the numerator and b is the leading coefficient of the denominator, what is the value of a divided by b? So they don't necessarily want you to tell them what a is, what b is, but what is a divided by b? What does that have to be? Go ahead.
It'd be 2 since the horizontal asymptote is 2.
Exactly. Since y equals 2 is the horizontal asymptote, then a divided by b has to equal 2 because the horizontal asymptote up here is at y equals 2. Very good. And again, kind of going back to Ashton's question earlier about the 3 roles. So this one, knowing that they're talking about the y-intercept, or the horizontal asymptote being at 2 and using the a over b, you know that the powers for this equation have to be what at the end? What do the powers have to be at the end? In your final answer. They're talking about the leading coefficients. Is it top heavy, bottom heavy, or equally heavy? Equally heavy, because you know it's the leading coefficients and it's at y equals 2. It's not at 0 and it's not a slant. So you know they have to be equally heavy. So the last question is going to refer to that. It says, in standard form, what is the equation of the function? Well, I always tell you it's easier to write it as factored form, and then you can multiply it out to get standard form. So what would the factored form be? What are we going to have on top? What are we going to have on bottom? We found the information up above. Who can tell me the factors of the top? Factors of the top. Rebecca?
X plus 7 and 2x minus 1.
2x minus 1, and what was the other one you said? X plus what?
Oh, for some reason for the y value put that, x plus 3.
Yeah, x plus 3. So that's going to be where the whole was canceling. Okay, so what goes on the bottom? Go ahead, Emma.
X plus 4 and x plus 3.
X plus 4, x plus 3. So if we think about our graph up above, at -3 we have the whole because these are canceling. Very good. At -4 we have a vertical asymptote. That's what this represents. And at positive 1/2 we have a 0. So that's what that represents. Very good. So everything is represented. Now we need standard form, so multiply it all out. After multiplying out, I got in the numerator 2x squared plus 5x minus 3. And then in the denominator, x squared plus 7x plus 12. So does the rest of our problem check out? Check your leading coefficients because it is equally heavy. Check your leading coefficient and check your y-intercept. Do they both check out? Are they correct, or do we have to adjust this problem? Remember, some of them will have a trick we have to multiply by something, but is this one okay? I see a leading coefficient 2 over 1. Well, I know that was correct from up above. My y-intercept has to be negative what? Negative 1/4, and that looks to be about negative 1/4 right there on the y-axis. So that is your final answer, and this is your standard form that they were asking for. Alright, so we have finished the notes up to this point. We're going to have the free response day tomorrow, so today is a time to finish anything up, try to get some loose ends finished, because free response day, quiz, then we're going to have a study day, and then you're going to have your test. Now your test is not going to be until the following week because we have a short week this week. So you'll have the long weekend to study for it, but it'll be the following week. So use today to try to finish up any homework or any notes that you may need to get caught up on from being out.